Hey everyone, and welcome. Have you ever looked at these massive AI models like BERT and just thought, there's no way I can use that, it's got to be way too complicated? Well, we're going to pull back the curtain on that. In the next few minutes, I'll show you exactly how to go from plain old text to a model-ready tensor in just a handful of super simple steps. All right, let's get into it.
So here's the game plan. We're going to go on a quick journey. First, we'll grab our first model. Then we'll see how to save it and load it. After that, we'll dive into how these models actually understand language. Next, we'll get our data into the right shape, and finally, we'll put it all together and go from text to a real result. Okay, first things first. Before we can do any of the cool stuff, you got to actually get a model. Simple enough, right? But that immediately leads to a pretty big question.
And this is where a lot of people get stuck. I mean, we're talking about models with hundreds of millions, sometimes billions of tiny little knobs or parameters that have been trained. It feels like you've been handed the keys to a spaceship with no instruction manual. So where do you even start?
Well, the answer is just so beautifully simple. It's a class called AutoModel. Seriously, think of this thing as the universal remote for AI. You don't need to know the specific commands for BERT versus, say, GPT-2. You just tell this one class the name of the model you want, and it does all the heavy lifting for you. It's incredibly powerful, but it's just one line of code.
You know, a name like BERT-based cased might look like a bunch of jargon, but it's actually a full spec sheet in disguise. BERT tells us the architecture. Base tells us the size, the one with 12 layers. It comes packed with all the pre-trained weights from Google's original work. And cased is a little hint that it cares about uppercase and lowercase letters. The best part? All of this gets downloaded and saved for you automatically.
So, you've downloaded a model from the internet. Awesome. But now what? How do you make it your own? Let's talk about how you can save it, load it back up whenever you want, and even share your creations with everybody else.
And again, you're going to love how easy this is. It's just one command, save pre-trained. That's it. You tell it where to save, and it packs up the entire model into a local folder. Suddenly, that huge AI brain isn't just some abstract thing in the cloud, it's right there, on your computer.
So if you peek inside that folder, you'll find two main files. First, there's config.json. Think of this as the model's blueprint. It describes the architecture, how many layers it has, all that stuff. Then you've got the .safetensors file. This is the good stuff. This is the model's actual brain, all the knowledge it's learned. You need both of these to bring it back to life.
So really, the entire workflow boils down to these three commands. You use save pre-trained to save your work. You use from pre-trained to load it back up, whether it's from your own disk or a totally new model from the hub. And then, when you've made something really cool, you can use push to hub to share it with the whole community. It's a really neat little cycle. Okay, this next part is maybe the most important concept in this whole process. We have to remember, transformer models do not understand words. They're all about numbers. So how in the world do we bridge that gap?
We have to perform a kind of translation. We have to convert our human language into the model's native language, which is numbers. And this magic trick, this conversion process, has a name. It's called tokenization. It's the absolute key to everything.
I mean, just look at the before and after here. Our nice simple sentence goes in, and out comes a list of numbers. Each of these numbers, or input IDs, is a reference to a word or even a piece of a word in the model's massive vocabulary. This is what the model actually sees when you give it text. Now, the tokenizer doesn't just swap words for numbers. It also adds in some helpful little markers called special tokens. For a model like BERT, it'll stick a CLS token at the very beginning of your input, and it uses a SEP token to show where one sentence ends and another begins. Think of them like punctuation marks that give the model critical clues about the structure of your text. Okay, so we can turn text into a list of numbers. Fantastic. But there's a catch. Before we can feed these numbers to the model, we have a little bit of a logistical problem to solve. We've got to get our data into the right shape.
Here's the issue. Imagine you tokenize a short sentence and a long sentence. You're going to get back two lists of numbers with different lengths, right? Well, models hate that. They work with tensors, which need to be perfectly rectangular, like a spreadsheet. A jagged, uneven collection of lists just isn't going to fly.
So how do we fix it? With a super simple, really clever trick called padding. All we do is take the shorter sentences in our batch and add a special padding token, which is usually just the number 0, to the end until every single sentence is the exact same length as the longest one. And just like that, problem solved.
Look at that! Both of our senses now have the same length. They form a perfect rectangle of numbers. This can be turned into a tensor that the model can process super efficiently. And don't worry, the model is smart enough to know it should ignore those extra zeros we added.
Of course, you can have the opposite problem, right? What if your text is longer than the model's limit? BERT, for example, can only handle 512 tokens at a time. If you feed it more, it'll just throw an error. The solution is just as simple: truncation. You literally just chop off the end of the text to make it fit.
And that brings us to the final step. We've met our model, we know how to save and load it, and now we've totally mastered how to prepare our data for it. So let's put it all together and see the magic happen.
So by combining all these little tricks, tokenization, padding, and truncation, we've successfully taken a messy batch of sentences and turned it into a pristine, perfectly shaped tensor. This is the exact format, the perfect meal that our model was designed to eat.
And this is the moment we've been working towards. After all that prep, all that shaping, how do we finally get an answer from the model? It's one line of code. You just pass your perfectly prepared inputs into the model. That's it. You have officially had a conversation with a massive neural network.
And there you have it, from a simple model name all the way to a final output. The tools to use these incredibly powerful AI models are way more accessible than you probably thought. You now have the keys to the kingdom, so the only question left is, what are you going to build?